Hello, this is a quick start guide to running through a Studio RM demo. So first thing we're going to do is we're going to create a new project with the links to all of the training data. So I've got the instructions on this PowerPoint, so you can rewind the video to go back to these steps if you want, but what I'm going to do is I'm going to go through this myself in the software. So in Studio RM, click on New Project, and we'll need to give the project a name and give the location somewhere in C database and maybe your client's name. So let's type MMG and then demo. Now if we click on Next, Next and Finish, the next thing we need to do is come to the project files control bar and click on this add existing files to project icon, and then browse for C database, DM tutorials, data, VBOP, Datamine. Press Ctrl A to select all of the files and then press open to link all of those files to the project. So here are those instructions again in case you missed. So after we've linked all of the files to project, we're ready to go, and the next thing we're going to do is just adjust the interface to give it a nicer look and feel for the demonstration. What you'll notice around the edge of the screen are things called control bars. It can often depend on how it's been previously customized as to where these will appear, but by default I think most of the control bars are displayed and they are scrolled. So what we need to do is make sure that on the left hand side we have the project files and the sheets only, and the project files controls the actual, or it contains the actual data files that we can load and manipulate. The sheets, which then shows the data we have loaded and how you can format the appearance. And at the bottom we need the command and the output window, which just show information around Datamine commands or design commands that we've carried out. On the right, nothing. So just break into the software, and if your control bars are around the edge like this, what we need to do first of all is take the first one, which in this case is project files, press on the pin button, which comes up with auto hide, and then for the command at the bottom we want to scroll over it and do the same thing, and then on the properties on the right hand side we want to also press the pin button to do the same thing. Now as you can see, by default we have a lot of control bars, but in reality we only need to see a minimum of 4 of these. So on the right hand side I'm going to just press the cross button to delete data properties and properties, and on desurvey report I'm going to delete this one as well. And then on the left hand side I'm going to keep project files, keep sheets, but I'm going to get rid of loaded data and customization and holes. And then finally, with my command and output control bars, if you left click and hold and drag the title, you can see these arrows appear at the edge of the screen, and if you put your cursor over one of the arrows you can see a blue shaded area appear. So I'm going to put it over this one here, which will dock that at the bottom of my screen, and it's important that these are docked and not just left floating. So once your control bars are in the correct place and that we have the project files and the sheets on the left, the command and the output at the bottom, and nothing on the right, then we can come to this Studio RM button and press the Save button to save the state of the project. The next thing we're going to do is we're going to load some data. So to load data we need to go to the project files control bar and select the files we want and then drag them into the 3D window. So the files that we're going to use, which are good examples for the demonstration, are vbholes, vbmintr, vbstopo, and vbmodgrd. For wireframes, you'll notice there's a wireframes points and a wireframes triangle folder in project files, but always and only ever load data from wireframe triangles. So come to the project files, open up the drill holes folder, find vbholes and just drag that into the 3D window. Then if I come to the block models, find vbmodgrd, drag that in. Then if I come to press this button with the 3 arrows, this will collapse my project tree to make it a little bit easier. And then if I come to wireframe triangles, find mintr and also stopo, which is just there. So now a few of the navigation options for using the 3D window. Obviously it's important to understand how to orient yourself around your data. So the important thing to remember is always pretty much hold down the Shift key, because this works in conjunction with the left and the right mouse button to rotate and pan the view. Other options include using the scroll wheel, and you don't need to use the Shift key with the scroll wheel. And if you move the scroll wheel backwards and forwards, you zoom in and out. If you single click the scroll wheel on some data, that allows you to adjust the rotation point. So to give an example, if I hold down the Shift key, left click, I can rotate. If I keep holding down the Shift key and right click, I can pan. If I take my fingers off all of the buttons and I just use the scroll wheel, I can move in and out. So it's a good idea to get used to using these controls, because if you zoom and pan and spin, you can quite quickly enable yourself to see different parts of your data. Now, one final option that was listed on the PowerPoint is using the single click of the scroll wheel. And what you'll notice if I do that is that I've just single clicked, and where I clicked goes to the center of the screen, and that is now the new rotation point. So this is a very useful function. So if I click on the bottom of drill holes, for example, in this case, each time I do that, it is making the bottom or the end of those drill holes the rotation point. So if you need to quickly zoom in on something, it's always important to have that at the center of the screen, and ensuring you understand how to use these 4 commands makes navigating around the VR window much simpler. It's important to get familiar with the Sheets control bar, because the Sheets control bar controls all aspects of loaded data. Turning on and off the display by checking the tick box, formatting the display by double clicking on the overlay name, and saving and unloading data, and a few other options too by right clicking on the overlay name. So first of all, if we go to the Sheets control bar, you can see that the data is displayed under the data types. So if I expand the data types, you will see the files that I've loaded. And if I just turn off the tick boxes, you can see that you turn off and on the display of the data. At the higher level, if you right click on the directory for wireframes, for example, and right click, you've got options to show all or options to transparent all. And if I show all, they should become solid again. In addition, if you double click on one of the file names, you can see the formatting options. So for example, on a wireframe, I can change the color to a fixed color of blue, click apply, and you can see my wireframe there is blue. And if I double click on it again, I can go back to using the legend which was previously using. So that option is available for all of the data types. And finally, you can use the Sheets control bar to unload and load data. If I right click, you can see the options to save or save as to give it a different file name, or unload. Alternatively, you can select an overlay, press the delete button, and then choose to unload the data. If you have unloaded data, it's simply a case of going back to project files and remembering which files we previously had, which are stopo, min.tr, and the block model file mod.grd, and the drill hole file bbholes. And there they are back again. As part of the demonstration, it's important to show the different formatting, and so here are some suggested options to adjust the formatting for drill holes, the block model, and the wireframes. But of course, you can do anything else that you want to choose as well. So first of all, for the drill holes, I'm going to add cylinders and labels. So I'm just going to rotate the data so that I can see it, and turn off the display of the other data, and then double click on the drill holes overlay, and first of all I go to the lines and symbols, and the first option allows me to display these as either a pixel line or a default cylinder. So if you choose default cylinder, you can see that they become fat and round, and you can change the width of the drill holes by pressing adjusting the scale. So it's generally nicer to see drill holes displayed as cylinders. One of the other good options we have available is to scale the drill holes by grade. So come to the size and change the column to AU, and if we click apply, you can see that the drill holes are now scaled by gold grade. So when they're larger, obviously the grade is larger, and when they're narrower, the grade is lower. So we can adjust how that looks as well. So again, just double click on the drill hole overlay and change the scale to make them all smaller. We can constrain the data, so the maximum gold value might be 300, which is skewing the cylinders. So we can cap that, in this case, to a maximum of 10. And if I click apply, you'll see that the cylinders now look a little bit more sensibly sized. The final thing to do is add a guideline, which is important because if the sample hasn't been assayed, it doesn't show up because it has an absent value. So using the guideline allows you to see the rest of the drill hole. So currently they're scaled on gold grade, but the color is based on end depth, which is just an attribute in the drill hole file, but not really something useful for viewing. So I'm going to change the column to lith, and by clicking this button just to the right, we'll create a default legend for the lithology, and this button to the top left allows me to show that legend, and if you click apply, you can now see the colors are representing the different lithologies, and now it's the formatting is set up so we can see the trend of grades by rock type. If we want to now add labels to the drill holes, again just double click on the drill holes and we'll come to the labels tab and click on the display labels option. By default, the borehole identifier is it's already been set up to display at the collar position and with a default yellow color. So if I click apply and close, you can see that the drill hole labels show the borehole identifier. If you want to add other labels down the drill holes, you can come to the labels and then click on new, and maybe we'll add the gold grade, and put 2 decimal places and then insert. Then we're going to put the position of the labels by segment instead of at collar or end of hole, which wouldn't look right at all. And then we're going to group by lithology. So if we've got several samples of the same lithology, it's going to give us a composite grade for that length of core. And finally, I'm going to choose the gold column, and I'm just going to click on this button to create a default gold legend. And click apply. And now you can see the grades. If you zoom in, the grades for gold appear, and possibly in this case it may be better to have the drill holes displayed using just a pixel line and not scaled, and then you can see the grades properly. But I'm going to turn that back on because I think it looks a little nicer, and I'm going to turn off my labels. And now I'm going to turn on my wireframes, and to make them transparent I can do this in 2 ways. I can double click on the overlay, and there's an opacity slider bottom left hand side, and if I click apply you can see that my min TR wireframe has become transparent. Alternatively, if I right click on the wireframes folder, I can go transparent all, and that just makes all the wireframes loaded equally transparent. Final formatting I'm going to show you is to display the models as scaled points. So double click on the mod GRD, and I'm going to choose the legend displaying gold grades. So choose the column AU and use the previously made gold legend, which was for the VB holes, and then click apply. And now I'm going to choose the display type as points and click apply. And now I'm going to go to symbols and choose to scale by gold grade. So displaying it like this is quite useful because, first of all, it uses far less of your computer's graphics power to display them as points, and these are just flat points instead of 3D objects. Also, if you often people want to display models as blocks, but the disadvantage there is the poor performance usually of the graphics window when we're displaying data as blocks, models as blocks rather. Plus you can only actually see the outside of the ore body. So if we're displaying as scaled points, it's easier on your graphics card, plus we can far more easily see trends in the data and how they happen to match up with the grades that we can see, in this case, in our drill hole data. Okay, so now we're going to take a look at some of the options to adjust the section in the 3D window. So first of all, in terms of manipulating the section, we first need to ensure that perspective view is turned on, and we need to turn on the section in the sheet's control bar. And then we're going to go through a number of options to turn on the clipping, make the clipping narrow and wider, adjusting the orientation of the section, and then dynamically moving the section through the data. And then we're going to finish up by creating 3D and 2D grids around our data. So firstly, if we open up Studio RM, go to the View ribbon, and we need to make sure that this perspective view is turned on, and you know it's turned on if it has an orange box around it. The second thing we need to do is turn on our section plane, and we have a folder for sections, and the default section always exists and it's always turned off by default. So if you click on the plus button, you can see that a sort of pink box appears, which is sort of wrapping around the hull of our data extents. And that is the section on which we can digitize and also add clipping. So in terms of adjusting the orientation of the section, we go to the sections part of the ribbon. I can change it from plan to north-south to east-west. And I can come over to the clipping and I can make sure I can clip on the outside or clip to the front or to the back, which means that I can preferentially clip data on one side or the other. Now, in addition to that, if I just maybe adjust the clipping to adjust the section to a north-south section, I can use the Edit Interactively option, and what that does, it adds these colourful arrows at the edge, and if I don't click on the arrow, I can just left-click anywhere in my section and left-click and drag and move it forwards and backwards, and that just pushes the section along the along the orientation that it's already in. If I turn my clipping on outside, you can maybe get a better view of that. If I want to use the arrows, I can then adjust the orientation of my section dynamically. So by clicking and holding on one of the arrows on the outside, you can adjust the orientation, and then if you left click and drag just anywhere within the section, you can pull that through your data. If I choose the blue arrows, this one will take it from vertical to horizontal. And again, when I've finished, I can just left click anywhere in the section and move it up and down. In addition, I can just go back to the section options to make it go to plan, to north-south and to east-west, and to turn off my clipping. In addition to the options on the ribbon, we also have the options always available on the toolbar, the viewing toolbar, and I have similar icons to adjust the section north-south, east-west, and plan, and as well as this button to interactively edit my section and toggle my clipping on and off. And that toolbar is useful because it's always you can always see it no matter what ribbon you're in. So I'm just going to turn off my clipping and also turn off my section for a second. And finally, we're going to look at creating some grids. So the first option is a 3D grid I'm going to show you. And to create a grid, you go to the Sheets control bar and you right click on the grid folder and go New 3D Hull. And by doing that, it automatically creates a grid wrapped around the hull of your data. And numbers get larger as you zoom in. Now, we wanted to make that slightly different. We could adjust the data in which the 3D grid wraps. So if I double click on where it says grid, I can go to the advanced options, and then instead of snapping to hull, which is snapping to the hull of all data, I can choose one of my files in particular, and in this case I'm going to put a grid around my VB holes. If I click apply, you can see that now that grid is applying just to my drill holes, and that grid also contains my wireframe and also my block model. Now if I just turn off that 3D grid and turn on my default section again, I'm going to go to a north-south section, and just move my section plane so it is right in the middle of my data, and turn on my clipping. Now we have an option to lock our section, which means that we will be looking perpendicular to our data, and once we're doing that, I cannot rotate my section. I can zoom in and I can pan, but I cannot rotate. So this is like the design environment of the design window which we had in Studio 3 and Studio 2. So now I can right click on grids and go to new section, and you can see that I have an orthogonal grid around my orthogonal view, and I can double click on the grid and maybe put lines on if I wanted to, but I'll turn those lines off, just put them back to ticks again. And then if I move my section plane, I move it forwards by maybe 20 meters, you'll see that the grid remains, and I can then move forwards and backwards in 20-meter increments, and the grid remains.